Hello, my name is Alejandro Morales, and today I'm very excited to be presenting my poster. So today we're going to be talking about the evaluation of immobility behavior that is caused by capsaicinoid homologues. Now, if you're not aware, capsaicin is a key pungent ingredient that is found in hot chili peppers, and it causes food to be spicy. It also has an analgesic property, though. It can desensitize nociceptors, which are also known as pain receptors. But its pungency limits its applications because a higher concentration of capsaicin would cause a significant burning sensation, which means that only lower concentrations are really effective. We decided to collab with Young Biopharma to synthesize YB compounds, which have a decreased pungency, so that pungency is minimized, and we can maximize analgesia through this. In our experiments, we observed a very bizarre phenomenon of immobility that was seen in mice who were given either capsaicin or a YB compound, which we will talk about more as we go on through this presentation. So the main assay that we used was a spontaneous behavior assay. And in this assay, mice were habituated in an enclosure, and then they received an intraplantar injection in their right hind paw that consisted of either capsaicin, YB16, one of our compounds, or a vehicle. And these mice were then placed into the enclosure for 120 minutes, and their pain behavior was scored as either biting or licking of that same right hind paw that they received that intraplantar injection. Their behavior was scored using a stopwatch, and it was scored as the total amount of time in each 5-minute interval that the mice was in the enclosure. Now, as I mentioned earlier, we also found that mice went through significant bouts of immobility, and immobility is classified as a mouse staying completely still with very minimal movement of their head. We decided to score this information as well. So we manually scored a 30-minute segment of a video, and we used an automated tracking software known as Animaze to automate this process, so that way we wouldn't spend a significant amount of time manually scoring the mice. And we compared the two using an ICC plot and found an R value of 0.96, which showed a strong correlation between our optimization of this Animaze software and our manual classification of immobility behavior, which gave us the green light to go ahead and score these mice using Animaze. As you can see on the right, we have examples of an active mouse and an inactive mouse. An active mouse is rearing and moving around. An inactive mouse is completely still, not moving around at all. As we can look at the results, the data we collected is reflected in these two graphs for the spontaneous behavior assay. The graph on the left shows the behavior in each bin, each 5-minute bin across the 120 minutes, the y-axis reflecting the amount of time they spent licking their paw, and the x-axis reflects the amount of bins. The graph on the right shows the spontaneous behavior, the total spontaneous behavior. And as you can see, there's a very significant decrease between a vehicle and a 10 microgram dosage of capsaicin, which is bizarre because you would expect this burning molecule to cause mice to lick and bite at their paw a lot more than a vehicle would. So as we look at our next set of graphs, I just want to let you know that the legend for all the graphs in this presentation are the same. So these graphs show the amount of time spent immobile. And the graph on the left reflects the amount of time immobile in each bin across the 120-minute period of time. The graph on the right reflects the total time immobile. And this is separated by each treatment. As you can see, there's a very significant amount of immobility that occurs in the 5 and 10 microgram doses of capsaicin, along with the 45 microgram dosage of our YB16 compound. Now, what can we take away from this? What does this data represent? We said that capsaicin causes a very significant amount of immobility compared to its YB16 analog whenever we're looking at the vehicle, right? And as I mentioned earlier, the spontaneous behavior mice displayed displayed a very little amount of behavior. And this is caused by sedation, the immobility that we just observed in those immobility graphs. And what can we do with this in the future? Well, we would like to analyze the pungency rating of each capsaicinoid homologue compared to the total time immobile to see if there's a correlation between pungency and immobility. And we would also like to do a future set of experiments to evaluate the impact of capsaicin-induced sedation to see what role it plays in its analgesic property. Thank you very much for coming to my presentation, and I hope you have a wonderful day.